So Mars Innovation is a center of excellence in commercialization and research. Our members include the universities and hospitals in Toronto, which represent over $1 billion a year in R&D. In the summer of 2010, we were first introduced to an otoscopy simulator out of Sick Kids Hospital. We met with the inventors and did some due diligence. The inventors had such a pipeline of ideas, we decided to build a company around it. Mars Innovation invested my time and over $50,000 in prototype development, patents, and initial incorporation of the company. We then looked for external funds and identified HTX, who also loaned us $50,000. In January of 2011, we incorporated, and by March, we had our first full-time hire on board. In April, we had a prototype at a state of development that we could take it around to trade shows, and we did 5 trade shows in 2011. Generated a huge amount of positive buzz and lots of leads. By September 2011, our first product was delivered, and we have over $100,000 in sale, all in less than 1 year. Mars Innovation saw the potential in OtoSim and continued to support OtoSim in the form of a convertible debenture to give us some cash flow to really push the technology forward. We now have a couple of staff, plus myself, and I'd expect that to grow to a half a dozen in the next couple of years as the product portfolio grows. This does not include local suppliers we draw upon for design and component manufacturing, which increases the number of jobs created. But let me let the inventors tell you the story of OtoSim.
Well, as the undergraduate director for otolaryngology, I noticed that the students had a hard time seeing things through the otoscope. It was easy to lecture and provide them with pictures on a large screen or from a page in a textbook. And certainly anybody can see that. But then I realized that what they really needed to do was to use single eye vision through an otoscope and to train their brains to pick up important anatomical landmarks and pathology by looking through the otoscope. So once we started doing that and experimenting with the earlier prototypes, we realized that the students were actually understanding what we were trying to teach them. And certainly this was going to translate into better performance as students and better ultimate clinical care.
I think the training of the medical student and the paramedical person who deals with ear disease has to be improved. There's been a lot of misdiagnosis or incorrect diagnosis that I've seen in the clinic, referred from general practitioners, pediatricians, and even sometimes, unfortunately, otolaryngologists.
For students to learn otoscopy, they're looking down this black hole, and you as an educator are trying to determine what they are actually looking at and that they really understand what you're talking about. And I found actually looking into the ear canal and trying to determine pathology of the middle ear and to make a diagnosis as a student and even as a junior resident was very, very difficult.
So we came up with this idea to actually simulate the ear and the conditions that affect the ear and be able to train our medical students a little bit easier.
Ensuring that the students have actually seen what you wanted them to see. And so in the traditional methods of teaching, you would rely on the students telling you that they've seen what you've asked them to see, but you couldn't guarantee it. So in developing the OtoSim, we wanted an ability to direct their vision through the otoscope and to point at specific features. In doing so, we could guarantee that they were indeed seeing the important features and also to teach them a systematic approach to identifying all the important areas of the eardrum. We were very fortunate to have Dr. Michael Hawk as a collaborator on this project. He has basically a career's worth of incredible variety of photography of the eardrum using very specialized techniques. And so clearly we have at our disposal is the finest quality images of various pathologies of the ear that is really not found anywhere else in the world. So we wanted to accomplish several features in a simulator. It had to be realistic. The students had to be used to using an otoscope and how to insert it into what looked like a normal ear, and then to have exposure to a wide variety of different pathologies so they could see various examples. and really to help them gain their confidence in recognizing important features within an ear.
I believe that by having simulation, you'll be able to show them that in a much shorter period of time. So it'll diminish the number of hours that you got to spend in the clinic trying to find different pathologies to educate if you will, the undergraduate or the student and the resident.
It had to be both Mac-based as well as PC-based. Ability to test one's vision, to test one's color perception, to test one's depth perception, to be able to see if you have the actual skills to actually be able to diagnose. And then the 1 centimeter size crystal clear image to allow the diagnosis to be made. All these things are actually built into the simulator as well. And then the ability to teach on mass as well. So one instructor can have multiple students simultaneously.
I think today that in most of the students, and many of the family physicians really probably overprescribe because of their lack of knowledge of the diagnosis of the different pathologies in the ear canal and the middle ear. In particular, in the summertime, you see a lot of children with otitis externa because of them swimming in pools, etc., etc. And I think that many of them believe that it may be coming from the middle ear. And in actual fact, you may be able to diminish the number of prescriptions that you will need. And I think it'll be reduced by about 50% once you educate the people going into practice. And I realize how difficult it is for us as educators to give them examples of all the different pathologies before they get out into their practice.
Well, like with any educational tool, you need to verify that it is in fact making a difference for student education. So you need to properly study these new tools. And what we decided to do is a randomized prospective trial. And it was clear from those results that the students that had the confidence and the skills acquired from the simulator were able to identify pathologies far better, far more accurately, and more quickly than the control group. The improvement in diagnostic accuracy was very striking. With such a limited amount of time on the simulator, we improved their clinical skills tremendously. But what really made a difference for me is the feedback that the students provided at the end of the course. And that is that they all felt more confident in their skills and certainly had developed an approach that they would continue to use in other courses and throughout their careers.
This is the future. There's no question that simulation will be integrated into education. Certainly as a chair and many of the rest of his leadership positions will see the many advantages of this. And as it is seen as a real advantage, I think we will see people purchase it more and more frequently. The quicker we just get this out here, tell people how important it is, I think the faster it will be adopted.
Any teacher in otolaryngology is looking for a tool to enhance their teaching skills and also to ensure that the students are learning. The data out there confirms that many physicians and medical students are not confident with their skills, and so I think we're all looking for some way to improve that.
The benefit is the right diagnosis means the right treatment. So anybody who is in a position to diagnose any ear condition should have OtoSim.